For my students, this lesson comes from chapter 9, section 2 in our textbook, and it's titled Quadratic Functions. So let's first start off by reviewing what the standard form of a quadratic function looks like. And here it is, y equals ax squared plus bx plus c. Now, the only requirement here is that a cannot be equal to 0. So you don't have to have this bx term and you don't have to have the c term, but you do have to have an x squared there. If you don't have an x squared, it's not a quadratic function. In the previous lesson, we talked about the effect of a. And so here's just a quick review of that. If a is a positive value, then your graph is going to open upwards. Remember, the graph of a quadratic function is a parabola. It looks like a U. So if the a value is positive, then it's going to open upward. If the a value is negative, it's going to open downward. And then the other thing that the a value does is that as the absolute value of a increases, the width of the parabola decreases. So as the absolute value of a increases, the parabola becomes skinnier. In that same lesson, we also talked about what the c value does. And so what the c value does is it translates your graph, your parabola, either up or down. So if this was a positive 2, what it would do is shift your vertex of your graph up 2 units. If this was a negative 2, it would shift it down 2 units. So this lesson, we're going to explore what the b does. So let's get to that. All right, so here's 3 different graphs of quadratic functions, all with different b values. Notice I didn't include a c in these just to simplify things. So remember, the c value would have shifted it up or down, but you can also see that the b value is also shifting these up or down, okay? But more importantly, if you look at these, x squared plus 2x, x squared minus 2x, and x squared plus 5x, the dashed red line here I added is called the axis of symmetry. Again, we talked about that in a previous lesson, but let's just add that. So this red dashed line here is called the axis of symmetry. And so what the b value does is it moves your axis of symmetry. So when the b value wasn't there, when the b value was 0, our axis of symmetry was 0. So the axis of symmetry was the y-axis. So the key thing you need to take away is that the value of b affects the axis of symmetry. All right, so where do we go from here? So it's really important when you want to graph a quadratic function that you can determine where the axis of symmetry and the vertex are. Remember, a graph of a quadratic function is symmetrical about the axis of symmetry. That means if you were to fold the graph over the axis of symmetry, it would match perfectly. So it's really important to find where that line is. Where's the line that divides our graph? Where's the line of symmetry, or the axis of symmetry? And I just noticed I spelled axis wrong here, so that should be an S, x6, okay. So finding the axis of symmetry and the vertex will help us in graphing. So here's the key concept here. You can find the equation of the line of symmetry, or the axis of symmetry, using this. X equals negative b divided by 2 times a. So if you plug in your b value, take the opposite of it. So if your b value was negative, you'd make it positive. If it's positive, you'd make it negative. Divide that by 2 times your a value. It's going to give you the equation of the line of symmetry, or the axis of symmetry. Okay, this value, when you find it, this also gives you the x value of the vertex. So your vertex, if we go back, should have labeled this too. So remember that this point right here is the vertex. And the vertex is either a maximum or a minimum. In this case, the vertex is a minimum. And actually in all 3 of these cases, the vertex is a minimum. If the coefficient of x squared was negative and these were opening downward, then the vertex would be a maximum. All right. So this x value gives you the x coordinate of the vertex. So once we have that, how can we find the y value of the vertex? Well, you just simply substitute in this x value into your quadratic function, solve it for y, and now you have the y value and you have the x value. And then we're going to use those to help us graph. And we're going to get to that. But first, let's go back to those previous three graphs we looked at. And let's use this formula to find the axis of symmetry. Okay, so we're going to go back here. I'm going to change my color to black. And so the axis of symmetry, that formula, I'm going to write it up here. X equals negative b over 2 times a. So for this one, so for this first quadratic equation, that would be negative 2 over 2 times 1. Remember, the a value here, the coefficient of x squared is 1. It's not written. So you take the b value, take the opposite of it, so make it negative 2, and then put it over 2 times 1. So you'd have negative 2 over 2, which is equal to negative 1. That's our axis or our line of symmetry. Now look at the graph. This dashed red line, where is it at? It's at negative 1. Okay, so this gives you where that line goes. And the line goes at negative 1 on the x-axis. So let's do the same thing with this other function here. So x equals negative b, so it'd be the opposite of negative 2. So that would be positive 2 over, again, the coefficient here is 1. So 2 times 1 is 2. And so that just simplifies to 1. So in this one, our line of symmetry or our axis of symmetry is equal to 1. So look at our dashed line here. Where is it? It's at 1 on the x-axis. All right, and so let's look at this last one here. We have room to fit this in here. Negative b, so it would be negative 5 over 2 times 1 again. So it'd be negative 5 halves, which if I simplify that, that would be negative 2 and 1/2. And so look at our line. Is it between negative 2 and negative 3? Absolutely it is. Okay, so this negative b minus 2 times a tells us where the axis of symmetry is. And again, once we have this x value, we can take that, plug it into our function, and find the y value. And then once we have that y value, now we know exactly where the vertex is. Once we know where the axis of symmetry is and we know where the vertex is, then it makes this a lot easier to pick points for your graph. And we're going to do a couple examples of that. All right, so let's get to that. So here's the first example I have for you. We're going to graph y equals x squared minus 6x plus 4. And the first thing that we're going to do is we're going to find the axis of symmetry. And so again, that axis of symmetry is negative b divided by 2 times a. So in this case, negative b, the opposite of negative 6, would be 6. Again, our coefficient on the x squared, the a value here is 1. So that's just 2 times 1. And so our axis of symmetry is at 3. Okay? So that means you could, if you wanted, you could put a dashed line here through x equals 3, a vertical line here. And we know that the right side of the graph and the left side of the graph are going to be symmetrical. They're going to be mirror images of each other. So let's go ahead and find the y value. So to find the y value, I'm going to substitute this x value into my function and find what y is equal to. And when I find that, I'll have the x and y coordinates of the vertex. All right, so I'm going to take my function and I'm going to substitute in 3 for x. So it's going to give me 3 squared minus 6 times 3 plus 4. Okay, so all I did was replace x with 3. I substituted in 3. So let's work on simplifying this. So that gives me 9 minus 8 18 plus 4. 9 minus 18 is -9, plus 4 is -5. So my vertex, coordinates of my vertex are 3, -5. And where did the 3 come from? It came from up here when I found the axis of symmetry. Because the vertex is always on the axis of symmetry. And I got the y value by substituting that x value into the function. So let's go ahead and plot that point. So 3, -5 is right here. Now the other thing we should think about is which way is this going to open? Is it going to open up or is it going to open down? And what determines that is the coefficient on x squared. If it's a positive value, it opens up. A negative value, it opens down. So our coefficient is 1. So this is going to open up over here. Okay. So I have 1 point. Let's pick 2 more points and see what we get. This will be easy. Let's plug in 0 for x. That'll be a good point to pick. And then let's plug in 1 and 2. How about that? Okay. So we'll plug in 0, 1, and 2. So when I plug in 0 for x, I'm just going to get that y equals 4. When I plug in 1 for x, and give myself a lot of room here, I'm going to end up with y equals 1 squared minus 6 times 1 plus 4. 1 squared is just 1. 1 minus 6 is -5. Plus 4 is -1. So this point is going to be 1, -1. This one up here is 0, 4. And then let's plug in 2. So I have y equals 2 squared. I'm going to go ahead and just write 12. So 6 times 2 plus 4. Again, I should have given myself more room so I could show my work better here. 2 squared is 4. 4 minus 12 is -8. -8 plus 4 is -4. Let me just double check that. 4 minus 12 is -8. Plus 4 is -4. So I have the point 2, -4. Okay, so now I have these 3 points. So let's plot those points. 0, 4, that's right here. And 1, -1. And 2, -4. So why did I pick points that are all on the same side of the axis of symmetry? Why didn't I pick some points over here on this side? Well, because I know that this is a symmetrical graph. So I know this point, it's mirrored over to the other side. So look, let me just, let's go ahead and add a dashed line in here for the axis of symmetry. I think this will make this easier to see. All right, we'll do that. So here's my axis of symmetry. I can get my blue here. So if you look over here, this point here, I want to mirror that on the other side. Well, how do you do that? Well, look and see how far away it is from the axis of symmetry. It's 1, 2, 3 units. So go 3 units to the other side. 1, 2, 3. And there's its mirror over there. This point is 2 units away, so mirror it 2 units away on the other side. This point is 1 unit away, so mirror it 1 unit away on the other side. So I didn't need to plug in points over here. Plug in points just on one side and then mirror them over the axis of symmetry. And now my least favorite part is trying to draw a parabola, which if you've seen any of my other videos, I'm not very good at this. I'm going to try a different technique this time. Let's see, I'm going to start with that. And then let's do this and connect this. Oh, that was terrible. I'm supposed to go through that point. Like I said before, I'm not an artist in any way, and this tablet I'm using is not the easiest thing to draw lines on, especially straight lines. So that's supposed to look like a U. So I'm going to have to ask you to use your imagination. And there's arrows on the end of this because this continues on forever. Just a quick review of something that we talked about in the last lesson. The domain of this, the domain, that's the input values. You can plug in any x values you want into this. So the domain is all real numbers. Okay, the domain is all real numbers. The range, so if you look at our graph, the range is the output. The graph is our output. That is the output of the function. That's what the graph gives you. Okay, so notice there are no y values below -5. All the y values are above -5. So for the range, we would say y is greater than or equal to -5. Okay, so that's just a quick review from previous lesson. All right, so let's do another one. All right, I got another one here. So we're going to graph -x² plus 4x plus 3. So step number 1, we're going to find the axis of symmetry in the vertex. So the axis of symmetry, again, is -b divided by 2a. So that's -4 over 2 times -1. Again, the coefficient on the x, there's a 1 there that's not written. So the coefficient is -1. So that's my a value. So that gives me -4 over -2. So -4 over -2 is +2. So my axis of symmetry is at +2. So let's go ahead, let's throw a line in there. Just because I think it makes it easier for everyone to visualize this. So here's my axis of symmetry. Here we go. I wish I had a tool that drew parabolas. That would be really helpful to me. All right, so let's go back and find the vertex. So remember, the vertex, we have the x value. This is the x value because the vertex is on the line of symmetry. So we have the x value, we need the y value. And to get that, we're going to substitute this x value into the function. So I'm going to take my function, I'm going to substitute in -2. Now be careful here. This is negative, and then in parentheses, oh, I thought I was substituting -2. Sorry. So -2 squared. It's not -2 squared, okay? It's 2 squared, and then you make it negative. This is something that a lot of students have a lot of trouble with. There are not parentheses around the negative and the x. So this exponent, this 2, is only on the x. So this is a power. A power is made up of a base and an exponent. The base is x, and the exponent is 2. And the negative sign is just sitting in front of that. So be really careful with that. What you're squaring is the value of x. So if x was -2, then I would be -2 times -2. X is +2, so I'm going to do +2 times +2. And then I'm going to bring this negative sign in, and it's going to become negative. Yeah, I know that's confusing, and a lot of students have trouble with that. So you might want to back this up and hear me say that a few different times, and hopefully it'll click. So +4 times 2, so I'm substituting in 2 for x, plus 3. So again, like I said, I'm going to do 2 times 2 is 4, and then I have this negative sign, and that's going to make it -4. And then 4 times 2 is 8, and then plus 3. So here comes my y value. -4 plus 8 is 4, and 4 plus 3 is 7. Okay, so my vertex, the coordinates of my vertex, the x value is 2, which I found up here in the very first step. It's the same as my axis of symmetry, and the y value is 7. All right, so my vertex is at 2, 7, and it looks like I didn't make my graph big enough. So instead of having to redo this whole thing, I guess I can, no. So here's what we're going to do. We're going to pretend that this is 2, 7 up here. All right. And now I need to pick some values to plug in. So we can pick values on the right side or the left side, but we don't need to pick values on both sides, right? 0 is always a really nice value to pick. So let's plug in 0, and let's plug in 1. And truthfully, you really only need 2 points. I set this up for 3, but when you're graphing, you really should have 3 points, but we already have 1 from the vertex. So we really only need 2 more. So let's plug in 0. If you plug in 0 for x, you're going to get y equals 3. So there's our first point, 0, 3. I'll go ahead and graph that. It's right there. Oh, and I forgot to mention, which way is this opening? Up or down? Well, now you can tell it's going to open down because there's the vertex. That's a maximum value. And the reason is because the coefficient of x squared is -1. So it's going to open downwards. All right, let's substitute in 1. And again, I should have given myself more room here. Same thing with this negative sign. Just be careful. It's not -1 times -1. It's 1 times 1, and then you make it negative. So that's going to come out to -1 plus 4 times 1 is 4 plus 3. So I have 7 plus -1, that's 6. So my next point is 1, 6. And that doesn't sound right. 1, 6. Oh, no, that's correct. So 1, 6. Again, I didn't do well with my graph here. So we're going to estimate that 6 is about right there. And then remember, all we're going to do now is mirror these points across to the other side. So this point is 1 away. So I'm going to mirror 1 away over on the other side. This point is 2 away. So I'm going to mirror it 2 away on the other side of the axis of symmetry. And then now my favorite part, I get to try to draw a parabola. One of these days I'll learn how to do this, but I'm starting to lose hope. So let's see how this goes. Well, it's not my worst effort. Should probably get the art teacher to help me with this. And there's my graph. Okay, so again, just a real quick review. The domain is all real numbers. The range on this one, so the range is your output. And so the range is going to be y less than or equal to, this point up here was 7. That was our vertex with 7. So y is less than or equal to 7. There are no values of y that are greater than 7. They're all less than or equal to 7. All right, so there's a lot of information in here. So if you need to back up, watch things a couple times, and hopefully you found this helpful. If so, go ahead and like and subscribe. And until next time.